my name is Kimura from the Environmental Department of Soma Corporation. This video will introduce the techniques of powder coat photocatalyst coating. It is nice to meet you and hope that there are more understanding after this video. First of all information in regards to photocatalysts is introduced in the powder coat movie. The great technology, the basic theory, and the actual practice used within the public is all visible for further understanding in the video. If you haven't seen the video yet, please see that video beforehand. Here we will discuss more about the powder coat's coating solutions, such as the different types and their applications, and also the additives from secondary materials. First, let me introduce you to the different product lines of photocatalyst solutions from the powder coat series. Powder coat series can be broken up to two different types. The two types are standard type and clear type. Moreover, the standard type is broken into the ST series and hybrid series. The solutions from the ST series only contain pure water, thus other than titanium dioxide, there are no other foreign materials making the water-based solution harmless. Adding additional technologies to these ST series is the hybrid series. And this is the clear type, in which the distribution of alcohols allows to increase the volatile to create a thin and dense film, and does not impair the design properties of the coated surface by creating a transparent film as possible. First, the standard type, the ST series. Here is the STP, STT, and ST. And the solution from the reformation of standard solutions via LAG and mold. Including these two, in total of 5 types are the standard types. Here we will discuss more about each solutions. First, the STP. STP is a water-based solution composed of only pure water and titanium dioxide. It is important to have crystallized titanium dioxide for a photocatalyst reaction. The titanium dioxide in the STP is not crystallized, but in the amorphous shapes. Therefore, just drying the STP coating will not show any photocatalyst reaction. After coating, heating it up over 200 degrees allows to create anatase form, which then creates a photocatalyst reaction. Over passing 800 degrees, the crystallized form of anatase will change into rutile form. In photocatalysts, the high activity can be found with the titanium dioxide is in the form of anatase. When it becomes a rutile form, the activity levels fall significantly, so it is important to be cautious. To summarize, coating on the surface then can stand more than 250 degrees. Less than 800 degrees of heating will create a strong photocatalyst film. For example, pottery dishes, exterior walls, porcelain tiles then can be found in washrooms can be coated. Furthermore, STP can be effective as an undercoat. Photocatalysts can break down organic matter. Thus, coating on surface that use organic matter such as paint, resin, plastic, and rubber will cause decomposition reaction where the photocatalyst film becomes unstable. It will also deteriorate the surface as well as discoloration will show. In order to avoid that, it is important to have a protective film over an organic matter, which is the undercoat. STP does not have a photocatalyst activity unless heated. In addition, drying at room temperature still can create a very dense and strong film. Therefore, it is possible to create an inorganic film without a photocatalyst function. The inorganic coating of STP becomes a protective film, and coating a photocatalytic functional film over that becomes a stable photocatalyst coating film for a long term. And that photocatalyst functional film as a top coat is the STT. STT is the product of specially heated STP where over 90% of it reformed to anatase form. If it is completely reformed into the crystallized form, the titanium dioxide will lose water solubility and will precipitate when separated from water. Titanium dioxide without water solubility is the same when it was in powder form. Thus, without any other solution, the photocatalyst will become a powder when dried, not in film form. To avoid that, STT is the solution crystallized just barely right before it loses the water solubility. The crystallized titanium dioxide that still has water solubility will create a coating that is strong as a metal chain. It is possible to have a stable photocatalyst coating on those smooth surfaces and more. ST is the mixture of STP and STT. The combination of strong dense coating of STP and strong catalytic function of STT is the ST. This ST as a photocatalyst is perfect for exterior and other coatings. The ST represents the Palcoat series and has the Photocatalyst Industry Association of Japan (PIAJ) mark accounting for self-cleaning, antibacterial, and air purification. Next, I will introduce the hybrid type. First, this is mold is for strengthening the mold inhibitory effect. They are used for frames of buildings, existing concrete buildings, various basic plants where presence of mold and algae exists due to high water absorbent areas, and also used for north side of buildings. And this is VLAG. This coating solution is mostly used in interior construction. Having the ST as a main component also contains titanium dioxide sol, which shows high reaction to visible light, and silver ions that include antibacterial and deodorizing function that makes this hybrid type. In addition, it also works with interior construction made with organic compound by having stable, fixing property, and adjusted to mineral construction. Thus, a stable coating is applicable without an undercoat for interior areas with lower amount of ultraviolet light. Next is information about clear type. These are the three types: clear P, clear T, and clear G. First, this is the clear P, which is the undercoat solution for clear types. It creates a colorless coating which does not alter the design of the surface almost at all. On the other hand, the standard STP type may show a slight trace of white from the coating. If there are any concerns to this, it is recommended to use the clear type. Clear P, in addition to the protective function, has a hydrophilic function. Thus, it suits well for materials with water repellency. Therefore, it is also possible to use clear P as an undercoat and ST for the top coat, depending on the material of the surface. And this is the clear T. Clear T is made from water-soluble titanium dioxide, pure water, alcohol, and small amount of additive. Because the concentration of alcohol is high, evaporation is quick and allows to create a very thin coating. Same as clear P, it is used when the user wants to avoid altering the design of the surface. And finally, this is the clear G. Clear G is coating solution for glass. Clear G is able to obtain a clearer coating than clear T. In addition to solution, includes the hydrophilic function. Photocatalyst itself has the ability to hydrophilic function, though in order to get a high level of hydrophilic reaction by photocatalyst itself, we need to have a coating with thickness of only 1 micron. This clear G has a high level of hydrophilic function and oxidative decomposition force that is mandatory to self-cleaning function with very thin coating. There are solutions available for different surfaces and situations, but depending on the circumstance of the worksite, the solution with high alcohol amount, the clear types cannot be used. In that circumstance, you will have to use the standard types. It is difficult to coat surfaces with high water repellency and need very difficult coating techniques. The additive for STP makes that easier. This additive solution contains surfactant function. By adding to STP, the level of hydrophilic function rises and helps to coat easier. And this powder is the thickener. It helps to control the adhesiveness of the coating solution, thus it makes it possible to coat by brush or rollers. Like this, the solutions are selected from the construction conditions, the surface material, and the design material, and other varieties of factors. And these are the photocatalyst solutions, Powcoat from Soma Corporation.